Okay. So I have shared the screen. Just let me know once you're able to see the screen, okay?
Yes, ma'am. I
Okay.
can see.
All right. Okay, perfect. So we are going to do this paper. Not all of it, but some of the questions, right? Okay. So let's get started. This is the very first question, and it is about integration. Are you guys familiar with integration?
Yes, ma'am.
Okay, perfect. Okay, so let's integrate this function. Okay, so we can say it's a simple algebraic function. So the rule is very simple. We'll add 1 to power and we'll divide it with new power, right? So we have to integrate 2 by 3 x cube. So we'll add 1 and the new power is 4. So we will divide it with the new power. Minus 6 x to the 1 by 2, we'll add 1 and now we have to divide it by the new power, which would be 3 by 2. So we will have 3 in the denominator and 1 in the numerator, right? Is this clear?
Yep.
Okay. And finally, for 1, we are going to have x and we'll write down the c. Okay. Let's just simplify this. This would be 1 by 6 x to the 4 minus, this is 1, this is 2. So this is 4 x to the 3 by 2 plus x plus c. Okay, so this was a simple 4-mark question where we had to integrate an algebraic expression. So I assume that this question is clear, right?
Yes.
Okay, let's talk about the second question then. Here it is. Okay, so show that x squared minus 8x plus 17 is greater than 0 for all real values of x. Okay, in this question, what we need to do is we need to show that this expression right here is a positive expression. Only then it would be greater than 0. So let's do that. Okay, now whenever you have a quadratic expression like this one, we have x squared minus 8x plus 17. We will try to complete the square because we know that whenever we have something in this form, let's say x minus a square or maybe x plus a square, square of anything is positive. So we have to use completing square method because we know we need to show this expression positive, right? So do you guys know how to apply completing square?
Yes.
Yes.
Okay, so we have x square, then I can write this as 2 into x into 4. Why? Just so I know this number, I'll add the square, I'll subtract the square just so it is mathematically correct, and then we had 17. Okay. Okay, now let's simplify it further. We are going to get x square minus 8x plus 4 square minus 16 plus 17. Okay, then we know that this basically is x minus 4 whole square plus 1. Okay, now this is a square, so this certainly would be positive, and this is plus 1, so this is also positive, right? Sum of any two positive numbers would also be positive, so this whole thing right here is positive. This implies it would be greater than 0. So we have shown this. Okay, we have shown this, that this expression is greater than 0, right?
Yes.
Okay, then we have the second part. Let's rub this just so we have the question.
Wait, miss, I have a question.
Yes, sorry. Yes, yes, yes.
Yeah, over here you do plus 4 squared minus 4 squared. Wouldn't those cancel out?
Yes, okay, I'll tell you. Yes, we did plus square and plus 4 square and minus 4 square just so it is mathematically correct. But what was the purpose of doing so? We wanted to complete square. Why? Just so we can get this type of an expression which is squared, okay? So obviously we will be using this 4 square in this expression just so we can write it equal to x minus 4 whole square.
Okay. So we don't cancel that.
Yeah, yeah, we don't cancel it because this whole thing, because I'll tell you, x minus 4 whole square is basically, how do we open the square? X square minus 2x into 4 plus 4 square, right? So this thing is basically equal to this thing right here. Okay, this thing right here.
Yes.
And this is why we added this 4 square and subtracted this 4 square just so we could get this thing. And why were we interested in getting this? Because we wanted this expression to be greater than 0, right?
Yes.
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 Okay. Are you 100% sure that you have understood this question?
Uh,
Yes or no? Yes, guys?
yes. Yes.
Okay.
Yes, ma'am.
All right, okay. So I have this habit of asking continuously, don't mind that, but only then I understand if the students have understood or not, okay? Okay. So I'll rub this and we'll do the second part. Okay. Right. So the second part is if I add 3 to a number, okay, so 3 to a number, right, and square the sum, and we square the sum, the result is greater than the square of the original number. The result is greater than the square of original number. This was the original number. So am I going to get this inequality? Right? When I read this English statement is basically equivalent to the mathematical inequality I
Yes.
wrote, right? Okay. Now let's read the
Yes.
question. State, giving a reason if the above statement is always true, sometimes true, or never true. Okay. All right. So we know that whenever we have any inequality, obviously it could be that it is true and not true, but it is never true for every number, right? I mean, we have to find the range of x first, and only then we can say that for which range of x is this inequality satisfied. Okay, so let's work on that. So let's open this up. We have 3 plus x square. I can write it this way as well. X plus 3 whole square greater than x square. So this would be x square plus 9 plus 6x greater than x square. Okay. Now I have x square and x square on both sides. I can cancel these two. And finally, I can take 9 to the other side. Minus 9. So I have x is greater than minus 9 by 6. This means x is greater than minus 3 by 2. Okay. All right. So this is what we have after our working. And this basically means that this inequality or the above statement is sometimes true when x is greater than minus 3 by 2. Okay, let's check that out. Okay, let's do it for x equals 5. Okay, when we have x equals 5, it certainly is greater than minus 3 by 2. So let's do that. This is the left hand side and this is the right hand side. Okay, let's find the left hand side first. So we have 3 plus 5 square. This would be 8 square, that is 64, and the right hand side would be x square, that is 5 square, that would be 25. So certainly left hand side is greater than right hand side because 64 is greater than 25. So yes, it is true for x greater than minus 3 by 2, right? And let's check for x equals minus 5, okay? So if x is minus 5, on the left hand side, we are going to have 3 minus 5 square, that would be minus 2 square, so we'll have 4. And on the right hand side, again we'll have minus 5 whole square because we had x square, this is 25. Now we can see that 4 is not greater than 24, okay? So clearly the answer would be that the above statement is sometimes true, particularly for x greater than minus 3 by 2. For example, for x equals to 5, it is true. It is true. And for x equals to minus 5, it is not true. Right?
Yes.
Anything? Anything which you guys would like to ask?
No, ma'am.
No, no,
Okay.
no.
All right. Okay. Let's talk about this third question. This is the second last question. Okay. So in this question, we have given that the point A has position vector this and the point B has position vector this. So find the vector AB. Okay. Before reading part A, let's just write down what we have been given in the question, right? So the data is position vector point A, right? So this would be OA vector from the origin. This is 4i minus 5j, and this would be OB because it is the position vector from point B. It is going to be minus 5i minus 2j. Are you guys familiar with vectors?
No, ma'am.
No?
No.
Okay. All right. Okay. So, right. So, okay, I'll try explaining this. So, in vectors, think about x's, okay? Think about x-axis and y-axis, and this is basically for I, and this is basically for j. Okay. Now, if we have 4i minus 5j, this is 1, 2, 3, 4. This is 1, 2, 3, 4, and then we have 5. Then minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, so this is a rough diagram, it's a graph. We have 4i minus 5j. Okay, so even if you guys don't know this, we can still do it because we know this is I, this is j. Where would be 4i minus 5j? So 4 on I, this is the I-axis, this is 4, right? This is the line for 4. And then we can do for j using a different color. Okay, so this is for 4. And for j, we have minus 5j. So this is minus 5 and this is the j-axis. So this would be the point, right? So this vector is going to be in this direction. And this is 4i minus 5j. Okay, forget about this question. We'll not talk about this question. Obviously, it's a demo class, so I'll explain this topic as well, but we'll not do this question, okay? Because it needs more content. Right now, you just have to understand how to look at vectors, okay? Right. And then we have minus 5i minus 2j. So this is the I-axis. Where is minus 5? It would be minus 1, minus 2, minus 3, minus 4, and minus 5, right? Just like we do for x and y, it's very simple. And for j, we have minus 2. So this would be the point, right? And when we say position vector, it basically is the distance from origin. So it would be a vector of this type, right? So this is for minus 5i minus 2j. Okay. So far, the only thing which you guys know is that a vector has two things, okay? It has x part plus y part, right? We are familiar with x and y axis. So even if we have I and j, we can deal with that, right? I axis is basically the x axis, and for j, we use y axis, right? So if we had 4i minus 5j, how do we plot this point 4 minus 5 on graph? How do we do that? So basically this is 4, right? And then minus 5 would be here. So this was the point. Since we are interested in finding out the position vector, it basically is a line from the origin in downward direction, right?
Yes.
Have you understood this, Nikal?
Yes, yes.
Are you sure?
Yeah, yeah.
Okay. Right. So let's do the last question then. It's okay if you guys have not studied vectors yet. Okay. So do you guys know equations and lines and gradients and all that?
Yep.
Okay, let's do this question then. Now this is the last question. So the question is, the line L1 has equation 4y minus 3x equals 10. Okay. The line L2 passes through the points this and this. Okay, this is what we have been given, and we need to read the question now. Determine, giving full reasons for your answer, whether lines L1 and L2 are parallel, perpendicular, or neither. So what do we have in two parallel lines? Their slopes are same, right?
Yeah.
So
The same gradient.
yes, very good. So if L1 and L2 are parallel, okay, this is what we use for parallel. M1 is equal to M2. M1 and M2 are basically the gradients, okay? And if L1 and L2 are perpendicular, this is what we have in perpendicular lines. The product of M1 and M2 would be -1. Yes, guys, do we know this?
Yes.
Yep.
Okay, so we know these two things. Let's find out M1 and M2 and then we are good to go, okay? So we will find M1 using this equation. I have to rewrite it because equation of a straight line is in this form, mx plus c, and this is the gradient, right? So we have 4y minus 3x equals 10. I need to write it in this form just so I have my m. So I can write it as 4y equals 3x plus 10, y equals 3 by 4x plus 10 by 4. So what do we know now? That m1, that is the gradient of line 1, is 3 by 4. Yes? Do we know this?
Yes.
Yes.
Okay. Now we need to find M2. How do we find that? We have 2 points of the line L2. So we can use the formula M2 equals, for any gradient, for any slope, we can use this formula y2 minus y1, that is rise over run, x2 minus x1. Okay. So this is going to be, okay. Now let's say this is x1, this is y1. Let's say this is x2 and this is y2. So what is y2 minus y1? It is 8 minus 1 divided by, we have x2 minus x1. What is x2? x2 is minus 1. What is x1? It is 5. So finally we have 8 plus 1 by minus 6. This is 9 by minus 6. So this implies that M2 is minus 3 by 2. Okay, now we need to check this. Is M1 equal to M2? No. M1 is 3 by 4, M2 is minus 3 by 2. They are not equal. So these lines are not parallel. And is their product equal to minus 1? No, it is not, right? 3 by 4 into minus 3 by 2 is minus 9 by 8, which is not equal to minus 1. So this implies that neither these lines are parallel nor perpendicular. Okay. So is this example
Yes.
clear?
Yep.
Yes.
Any questions? Anything which you guys would like to ask?
No.
Okay. Right. So